Last week we talked about measure of central tendencies. So under that we made mention of the mean, the median, and the mode. And we also talked about the various ways by which we can calculate them. So today we will be considering measure of dispersion. Measure of dispersion. So when we say dispersion, it means to scatter something. So if you want to measure dispersion, that means you want to measure how scattered a given data set is. So let's take an example. So here now we're given the scores of 10 students in both mathematics and economics. So let me list out the scores. Let me represent mathematics with FTH and economics with ECM. So for the 10 students, we have 35, 36, 46,
48,
okay,
58,
58,
62,
62,
65,
68,
78,
78,
84.
and 84. Okay. So, and for the economics,
47,
47,
55,
55,
46,
46,
62,
62,
60,
60,
63,
63,
70,
70,
57,
57,
58,
58,
61.
61. Okay. So, okay, these are the various scores of the 10 students. So, to know how scattered they are, we can decide to represent them graphically. And at the same time, we can also decide to find their range. And how do we find their range? We pick the lowest number. So for range now, the lowest number for mathematics is what? 35. 35 is the lowest number. Then the highest number is 84. So we subtract that lowest number from the highest number. That's 84 minus 35. So which will give us 49.
49.
Yes. So this is for mathematics. But for economics, the lowest number is 46, right? Then the highest number is 70. That's 70 minus 46. So that gives us a range of 24.
Yes.
Yeah, 24. So from here, you can actually look at it that this one is more spread. The mathematics scores are more spread than the economic score using the method of range. So another way for us to determine it is by representing it on something we call a scatter diagram. Can I? Yeah.
Yes.
Okay. So we want to represent it on the scatter diagram. So I want this place to represent my mathematics, while this one will represent my economics.
Yes, scatter diagram.
Yes, for the scatter diagram. This is point 0. So I'm going to graduate it from 0 to 100. 10, 20, 30, 40, 50, 60, 70, 80. So let me just make this one light. So this is 90, 80, 70, 60. This is 50, 40, 30, 20, finally 10. For the mathematics, let's now start representing them. 35. So you can say 35 will be in between 30 and 40, right? Then the next one is 36, slightly above 35. The next one is 46. 46 is somewhere around 40 and 50. Then we have 48. So let's make this one 48 and make this one 46. So the next one we have 58, very close to 60. The next one we have 62, above 60. Next, 65, in between 60 and 70. 68, somewhere close to that. Then 78, before we finally have 84. Then the final one is 84. So this is for mathematics. Let's do the same thing for economics. The first one we have is 47. 47. Then next we have 55. Then next we have 46. 46 is just going to be below 47. Then we have 62. 62 is above 60 a little. Then from 62 we have 60. Then 60 we have 63. Then from there we have 70. 70 we have 57. 57 is going to be somewhere around here. Then we have 58. 58 is still going to be somewhere around here also. Then we now have 61. 61 is going to be in between 60 and 62. So looking at these two uh, points for the two subjects, which one is more spread than the other? Mathematics. So that means once again we are right. We use range the other time. From the range of 49 to 24, we can see that mathematics has more dispersion than economics. Then using this diagram, so you can still see the same thing. So the it is possible for the two to have the same mean, the same average, but their dispersion is going to be different. So if we decide to take the mean of these numbers, we are going to get the same thing. Can we try taking the mean? If we add everything here together, it's going to give us about 580. 35 plus 36 plus 46 plus 48 plus 58 plus 62 plus 65 plus 68 plus 78 plus 84. That's 580 divided by 10. The mean is 58. X bar for this one equals to 58. And if you do X bar for this one also, it's still 58. But their dispersion is different. So, under the measure of dispersion, we have two major methods that we use to measure dispersion. One of it is using the range, that's the first method, while the second one is using the standard deviation. So, standard deviation is also called the root mean square. The root mean square. So, we've actually considered the range at first. That was what we did the other time. That we subtracted the lowest value from the highest value. So the next one we're going to now is the measure of the standard deviation. So out of all the methods of measuring dispersion, standard deviation is the most efficient method for measuring the dispersion. So this is because it takes variable every variable into account. You know, the one we did here the other time, we just looked at it by eyes. That okay, looking at this one, which one has the more spread, has the higher spread, and we just concluded that it was this one without any value. Whereas when we're doing range, we just subtracted the smallest from the highest. So we only consider the smallest and the highest. But in standard deviation, we consider all the variables, not just one. We are going to consider all the variables. So now we are going to be taking the standard deviation for ungrouped data, the raw data. There's no frequency distribution. Last week we talked about the raw data, we talked about the frequency distribution, and we talked about the grouped frequency distribution. So this one now, it is not a frequency distribution, it's just a raw data. So we want to consider how to calculate the standard deviation for an ungrouped data.
Standard deviation.
Yes. So we are considering ungrouped data. So the standard deviation for an ungrouped data is given by the formula Sg is equal to the square root of summation x minus x bar squared divided by n, which can also be rewritten as the square root of summation d squared divided by n. This is the formula for calculating the standard deviation for an ungrouped data. So
For ungroup.
yes, for ungrouped, so ungrouped data. So let's take this as an example. This particular mathematics. So we want to make mathematics an example now. We want to calculate the standard deviation for the scores of 10 students in mathematics. So from the formula, we need to calculate our mean and we need to know our total number. So from here now, we can say our total number, our n is equal to 10 because we have 10 students. And we've also calculated our mean here the other time. So x bar equals to summation x over n, which is equal to 580 over 10, which is 58. Exactly. So we've done it here the other time. So the next thing we need to do, we just need to draw the table. The table to subtract our mean from each of these numbers. So I want to erase this one now. So please, when you are done, let me know so that I can erase it.
Minus S bar.
Yes, minus x bar.
Okay, I'm done.
Okay. Okay, so we've been able to calculate our mean as 58. So we'll be subtracting that mean from each of these variables. So the first one is 35. 35 minus 58, what does it give us?
35
Minus 58.
minus 57. So, okay, the minus
Yes,
that's
that's mean. The next one is d squared, which is equal to x minus x bar squared. So 23 squared, 529, 22 squared, 484. Next one is 12 squared, 144, 100, 0, 4 squared, 16, 49, 100, 20, 400, 676.
Our d squared is the x minus.
The d squared.
Okay,
D squared is the square of
this.
d. No, this is our d.
D.
Our d equals to x minus x bar.
Yes.
So squaring it
To give us this.
will give us this. So after squaring, we will now find the sum of the square. So 5676 plus 400 plus 100 plus 49 plus 16 plus 100 plus 144 plus 484 plus 529 2498 2498. So that's the sum. Then our n, like we said the other time, our n is equal to 10. So remember from the formula is summation d squared over n, then the square root of everything. So now inputting this into our formula, we don't need this. Standard deviation equal to summation d squared over n. So it's equal to the square root of our summation d squared is 2498 divided by our n is 10. So from here we can now say it is the square root of 249.8. So which will be equal to
24 x. I thought that's 2498.
yes sir. The 2498 is the addition of the square of the deviations. This is it.
Yes.
So putting it here, no, this one means the addition, and that addition is what we did here.
Yes.
So this is the addition. So divided by n, the total numbers, that's 10. So that's 249.8. And finding the square root, our standard deviation is 15.81. That's our standard deviation for mathematics. And we need to know one thing. Variance is equal to standard deviation squared. Variance is equal to standard deviation squared.
Variance is equal.
So now that we've been able to estimate the standard deviation for mathematics, let's also do the same thing for economics. Rewriting the data again, we have 47, 55, 46, 62, 60, 63, 70, 57, 58, and finally 61. So from our calculation, the mean is 58. So the d now, the deviation from the mean, is the mean the x minus the mean. So this is 47 minus 58. So minus 11. The next one is 55 minus 58 minus 3. This one is 46 minus 58 minus 12. This is 62. This is 4. This is 2. 63. 5. 70 minus 58. 12. 57 minus 58. That's minus 1. And this one is 0. 61 minus 58 should be 3. Yeah, 3. So just as we've done before, the square of the deviation, this one is 121, this one is 9, 144, this one is 16, 4, 25, 144, 1, 0, 9. So adding everything together, 121 plus 9 plus 144 plus 16 plus 4 plus 25 plus 144 plus 1 plus 0 plus 9 equal to 473. 473. So this one is our summation this way. So our standard deviation here becomes the square root of 473 divided by 10. That is the square root of 47.3. That's our SZ equal to 6.88. So from the previous example, when we tried to calculate the standard deviation for mathematics, we saw that it was 15.81. Yeah, and now the standard deviation for this course in economics is 6.88. So you can see that this is smaller than 15.81. It is more packed together. So that's just the interpretation of the values we got.
Which is math is more
Spread, yes. It is more dispersed than economics. So that's the conclusion. So we've successfully done the standard deviation for an unmixed paper. So listing out the steps on the material, page 32. The steps to calculate the standard deviation for an ungrouped data. Summarizing the steps, where x bar is the mean and x is any set of number. So the first thing for us to do is to calculate the mean. Then the second thing is to calculate the deviation from the mean. The deviation from the mean is our g, which is equal to the number, the variable, minus the mean for each of the variables. To calculate that. Then the second thing to do is to calculate the square of each of the deviation. That's d squared, which is on our third column here. D squared is x minus x bar all squared. So that one will help us eliminate the negative sign, which is in the deviation. So the next thing for us to do is to find the sum of all the squared deviations. So this square deviation, add everything together. That's the sum of the square deviation. So after that, we will now take the mean square deviation again. That's divide it by n. That dividing it by the total number. Then finally, we find the square root to give us the standard deviation. So like I said the other time, standard deviation can also be called the root mean square deviation. The root mean square deviation from the mean. So now we'll be checking an example on how to find the standard deviation for a frequency distribution. So let's make use of this table. Let's take this table for example. Distribution. So example. example now. We want to find the standard deviation for the given set of data. So here we'll be given the variable and the frequency of the variable x. The frequency of the variable is f. That's what will be given in the question. So we have 1 to 6. 1, 2, 3, 4, 5, 6. Then how frequent they occurred is 4, 9, 11, 13,
14,
10,
10,
and 3. Yes. So the general formula for finding the standard deviation of a grouped frequency is given as S equal to square root of summation f x minus x bar squared over summation f. This is the general formula, which means in this one we need to find our total frequency, which is summation f, which is summation f. We need to find our deviation from the mean, which is also the same thing as t. We need to find our frequency multiplied by deviation from the mean. Then we need to find our mean to begin with. So, and to find mean, we know that x bar for a group frequency distribution equal to summation fx over summation f from the previous class. So that means we have to find our fx also. So here fx 1 times 4 is what? 4. 2 times 9,
18,
3 times 11,
7,
4 times 13,
52,
52. 5 times 10, 6 times 3, 18. So the addition of everything here gives us 1
75.
175. Okay. 175. Yeah. And the total number of the frequency is what? 50. So which means our mean x bar, equal to 175 divided by 50, which is equal to 3.5.
Yes, 3.5.
Yes. 3.5. That's our x bar. So we need to find our x minus x bar. So 1 minus 3.5 is what?
9 minus
1
1
minus 3.5
minus 2.5.
minus 2.5. This one is minus 1.5. This one is minus 0.5. This one is 0.5. This is 1.5. And finally, this one is 2.5. So squaring it, x minus x bar squared. That's 2.5 squared. That's 6.25. Then next we have 1.5 squared. We have 2.25. 0.5 squared. That's 0.25. This one is also 0.25. This one is 2.25. Not yet. This one is 6.25. So is the mean, yes. We'll soon go to assembly. Eh? The variables. So we have 6.25 plus 2.25 plus 0.25 divided by 2. So that's 17.5. 17. We don't even need to calculate it here. So the next thing we have to do from the table, from the formula, is to find f multiplied by each of these values. F into x minus x bar squared. So that means this will multiply by the frequency. 6.25 times 4, which will give us 25. So the next one is 9 times 2.25. 9 times 2.25. 9 times 2.25, which is 20.25. Then the next one is 11 times 0 times 11. That's 2.75. Then the next one is 13 times 0.25. That's 3.25. So 2.25 times 10, that's 22.5. Then 6.25 times 3, that's 18.75. So we will now find the summation of this one. 25 plus 20.5 plus 20.5 plus 2.75 plus 3.25 plus 22.5 plus 18.75. That's 365. 365. Yes. So 365 is what we got from here. And from the formula, it is the summation of this divided by the summation of f, and find the square root. So here now we can see our standard deviation equal to square root of 365 divided by 50. So 365 divided by 50 will give us 7.3. So finding the square root of 7.3 will give us 2.7. 2.7, that's the standard deviation. Sorry, I think I must have pressed the calculator wrong. Here is not 365. If you add it together, it is.
Yes.
Oh, I wrote 275 instead of 2.75.
And you said it too. That's what you call.
Yeah, that's what I called. But with my calculator, I pressed this one, it did not press. So now it's 92.75. 92.75. So that's why it's better to press the calculator, like for more than one person to be pressing the calculator. Like there's a mistake, be able to get it. Like, it's not easy. I'm talking about for the sake of this tutorial, not inside the exam. So the square root of answer is 1.36. 1.36. So is there any question from here before we move to the assumed mean method? If the standard deviation is 1.36, what is the variance? The variance is just the square of the standard deviation. So that means our variance is just 92.75 divided by 50. That's our variance. Because if we square, if we get yes, this is our SD, which is the square root of variance. So everything inside this square root is our variance. So it's after you now find the square root of the variance that you get the standard deviation. So if you are given the variance and you have to find standard deviation, just find the square root of the variance. If you are given the standard deviation and you have to find the variance, just square the standard deviation. So that's just that about that. So moving on to the method of assumed mean. Method of assumed mean. So you could remember from last week, sorry, from the last class, not last week now, that we said the assumed mean for a frequency distribution is the same thing as assumed mean plus summation f minus assumed mean divided by what? Divided by summation f. So this is what I just said. X bar is the same thing as m plus summation f x minus m divided by summation f. This was what I said last week.
Yes.
So what we want to do now, it will not even involve us using this formula. There is a formula directly for standard deviation when we are assuming a mean. So we've been able to get this one as 1.36. So we want to use that assumed mean method and see whether we are still going to get the same 1.36 or we are not going to get it. So I'll write the general expression of it. The general expression is equal to standard deviation equal to the square root of summation f d squared over summation f minus summation fd over summation f all squared, where our d is equal to x minus m, and our m is the assumed mean. Do you understand? Like, do you get the? Did you get the
Formula.
The formula, yes.
Sorry, sorry. It's got to x minus.
So
I think n is equal to assume
yes, it's the assumed mean. So in this case, we do not need this. Okay, so from here now, from the formula, the first thing we need to do, which mean are we assuming? What should we use as our assumed mean? Just look at this number and just look at it. Well, which one should be the average? Anyone. Let's pick 3. Let's use 3. Inside the material they use 4. So let us use 3 in our case. So let m equal to 3. So the first thing is to do x minus m. So x minus 3, that's 1 minus 3 is what? Minus 2. Yes. Then for this one, 2 minus 3 minus 1. 3 minus 3 is 0. Here is 1. Here is 2. And here is 3. Yes. So the next thing to do is to find the square of that deviation. Now we are using assumed mean now. So the square of what we got here So this one is 4,
One.
1, 0, 1, 4, 9. Yes. So, and from here, f multiplied by d squared. That means this frequency multiplied by this. So 4 times 4 is what?
4 times 4 is
16. 9 times 1, 9.
9.
11 times 0,
0.
0. 13 times 1, 13. Then 10 times 4, 40. 3 times 9, 27. So, then for fg, f multiplied by d, this multiplied by this. So 4 times minus 2 is what? 4 times minus 2, that's minus 8.
Minus 8.
9 times minus 1, that's minus 9.
Minus
11 times 0 is 0. 13 times 1 is 13. 10 times 2, 20. And this one is 9. So here we need summation fg squared. So fg squared, we need the addition. Then summation fd also, we need the addition. We need the addition of summation of fd. So if you add this one together, 16 plus 9, that's 25. 25 plus 13. Let me press some calculator. 16 plus 9 plus 13 plus 40 plus 27 is going to give us 105. 105. That's what this one gives us. Then the solution of this one, minus 8 minus 9 plus 13 plus 20 plus 9, that's 25. So we can now substitute everything back into our formula. So going back to our formula, the standard deviation, looking at the formula from the top, is equal to the square root of summation fd squared, 105, divided by our summation f, 50, minus the second one is summation fd. Our summation fd is 25, divided by summation f, 50. So which will be equal to 105 divided by 50 squared.
Okay.
Squared.
Okay.
So from there, here is going to give us
25 square.
105 divided by 50 minus open bracket 25 over 50 is 0.5. 25 over 50 all squared. So it gives us 1.85. Yes. So and the square root of 1.85 is 1.36,
Yes.
which is the same thing as what we got in the first place.
Yes.
So that's just it. That is just it. With the assumed mean. So they actually use an assumed mean of 4 inside the material. They use an assumed mean of 4 inside the material. So using an assumed mean of 4, or you are using an assumed mean of 3, or assumed mean of 2, it's still going to give you the same thing. So, any question before we proceed? So this same method can also be applied to that of ungrouped using assumed mean. So it can also be applied. So the only difference is just that this one now is going to be summation d squared over summation n, over n. Then this one is summation d over n squared. That's very different. If we want to apply this same formula to ungrouped data, so we'll be going to a grouped ungrouped, the one that doesn't have frequency. once you can see frequency, no, it is not group, it is frequency distribution. So grouped frequency distribution is the one that has class interval. So that's what we're going to know.
But I know group data usually have
Interval. Yes. So this same formula is still going to work for it. Well, before that, let's consider without assuming.
So doing using assume mean, you want to use the way you get your normal assume mean to calculate mean, then how you use it to calculate.
No, we won't do it that way. We don't need to calculate our mean again. It has been included inside the formula. Remember, the formula has minus that one, so it has been included. So standard deviation for grouped frequency distribution. So for a group frequency distribution, the normal way to do it is what we've been doing since. All we have to do is to find the class center. So once you find the class center, that class center will now represent our x. The first thing we have is class interval, then we have frequency. Let's take an example. Yes.
Table 15.
Yes, that's page 36. Wow. Which is the second table page. So according to the material, they used only the assumed mean method. They didn't use the direct method.
That is in the past place for this class.
Yes.
They don't collect.
Eh?
They don't collect it.
I did not.
Like literally don't collect it.
He did not correct what?
And like he did not collect the question.
Oh yeah, I thought he collected it, but
Because I know it's used to collect it.
There's no for it. I've seen 2 years like that, or maybe 37.
For this one.
Yeah, for this course. But the problem is volume 2 is not there at all. So I think our set is the first set that we have volume 2 inside.
Maybe they don't use volume 2.
You already said it's not using volume 2 for test. So for exam, I believe it's going to use it. Okay. Yeah. We're almost done. So let's take this example. Table 16 shows the height of some people. So and we have how many classes? 1, 2, 3, 4, 5, 6, 7, 8. Yeah, page 36. Table 16 on page 36. 1, 2, 3, 4, 5, 6, 7. Yeah, 7. Sorry. So and we have it as follows. So class interval. The first one is 150 to 154. So if you have 150 to 154, what's the range of the class? The range of the class is just 4. But the range of the class is 4, but the number of values inside each class is 5. Because we have 150, 151, 152, 153, and 154 making 5. But the range is 4. How spread? Yeah, it's just 4, 4. 160 to 164, 165 to 169, 170 to 174, 175 to 179, and we have 180 to 184. So basically, the difference between this and the former one we just did is just the group, the group that is there. So given the frequency here is 4, 14, 26, 32, 21, 10, and 3. So the first thing for us to do is find the class center. Class center is just this plus this divided by 2. Okay. So that means 304 divided by 2. That's 152. 152. So 152, this one is 155 plus 159 divided by 2. That's 157. So 157, this one plus 5 again. That's 162, 167, 172, 177, and finally we have 152. So we said we want to use the normal method to estimate it. And using the normal method, it is the same thing as SD equals to summation, square root of summation f x x bar squared divided by summation f. But in this case, we don't have x, we only have c. So that means c is going to replace our x. So this will become c.
What's C?
Class center. So c is going to replace our f. And we have this.
So you have the upper and lower limit level too.
Yes. So now that we have this, I believe the first thing for us to find is to find our mean and the mean of the class centers. So, and to find mean, we need FC. I think the number is going to be big, so that column needs to be bigger.
Probably you should try to write on the side because I think you are blocking what you are writing.
Oh, okay, thank you. Well, subsequently, shall like as we move on, I'll just be leaving there so that you can see. So FC 4 times 152 is what? 152 multiplied by 4. 608. Then the next one, 14 times 157.
2198.
Okay. Then the next one, 26 times 162.
4212. 4212.
Okay. Then the next one, 32 times 167.
5344.
5344. Then the next one is 21 multiplied by 172. 3612. Then the next one is 177. Then 182 times 3.
546.
546. Okay. So we know that at the end of the day we have to find summation of functions. So our summation f is what? 4 plus 14 plus 26 plus 32 plus 21 plus 13. Okay. That's one thing. Then our summation.
Yeah, use the assuming method.
Yes, I want us to use the normal method so that we now go to the assuming
normal
method. Yes, this is the normal method. So we just compare our answer. Or we do the assuming method. So adding the FCs together, we have 608 plus 2198 plus 4212 plus 5344 plus 3612 plus 1770 plus 546 182,090. Ow. Sorry, 18,290. 18,290. And we have up to 18,000. I doubt it.
5, yes, 5 plus 9.
Okay, do we have 9? This is 9.
5, this is 9.
This is 2. This is 3. Oh, it's possible.
That's 9 plus 3 already. That's like 12. 12 plus 2. That's 14. 14
Yeah,
plus
it
1.
is possible. So, we need to find our mean now. Our mean is this over this. Summation FC. X bar equals to summation FC over summation F, which is 18,290 divided by 110. So our mean is 166. Yeah. 166.27. So this is our mean.
I want to provide all this naira right inside this table like this. How to do the expression of that.
Yes. Within
the table.
Yeah, within the table. So just try as much as possible to show workings. As the quote, show workings.
It's not everything that you probably have to know how to show working like that. Just like
so will this thing be enough? Okay, c minus x bar. So 152.
So that this is minus f bar. If you want to do it, you should try to write it out.
You can use two. Okay, write it out for each. So I have 15.
We'll try one past question. So
152 minus mean I'm going 152 minus 166.27. So this one gives us minus 14.27. Please, what's the next one?
Our S bar is the mean.
Right.
Nothing shall be impossible. Your kingdom will.
So 15.73. So the next thing to do is to square this. C minus x bar all squared. Then the last thing is now going to be f c minus x bar all squared. Equation is important. I'm telling you that.
Without 14.27.
This one? Yes, 14.27. 14.27 squared. You are not pressing calculator again. 203.63. Okay. Then 9.27. 85.93. Then 4. 18.23. Then 0.73. 0.53. Then 5.73. 32.83. We went to adding 3 right? Then 115.13.
You notice when I was doing the inside the handouts, you not put everything in one table like this.
So we now square the
I bet you. No, I'm down. So we start multiplying 4 times 203.63. 814.52. Then 14 times 85.93. 12 points. Sorry. 1, 2, 0, 3.02. Then 26 times 18.23. 473.9. Then 32 times 0.53. 16.96. Then 21 times 32.83.689. Do you know what's funny about this thing? Is the fact that all I just need to do is to put this and this inside this calculator. And like this table now, I just need to insert these two things inside and to calculate the variance, calculate the mean, calculate the standard deviation.
Well, I don't know what to show you.
Just to know that I'm correctly. After I'm done, I'll just put it there. Let's just show it out. So this one is 10 times 6.
When you put that on calculator, just write
No, I'll just write it somewhere that okay, oh, this is what I'm working towards. Anything you iterate again, 3 times 2.
Is there iteration?
Now.
What if you don't do mistake for calculator?
I go first press the calculator like 2 times, 742.29. 29. So what we need is just the addition of this over the addition of this. Let's add 814.52 plus 1203.02 plus 473.98 plus 16.96 plus 689.43 plus 1151.3 plus 742.29 is equal to 5091.5. So yeah, we've been able to estimate everything we think we need.
But they are not everything you need.
So the final thing to do is to just infuse everything inside the formula. And from the formula we have our standard deviation to be equal to what we have up here. And substituting is going to be 5091.5 divided by 110. Divided by 110.
That should be.
So square root of 46.29. So square root of our answer is 6.8. So 6.8. That's the standard deviation. So and mind you, it is possible, from the question, I said we're given the height. This thing is an height. So that means our final answer must be in centimeters. The unit of the height we're given is what you are going to use. So that's just it. So only few things are going to change. Calculate it. If you are calculating, calculate yourself.
No.
So our class center is not going to change. FC.
Question 2.
No, we want to use assumed mean.
Get the same thing.
They use assumed mean inside the material, and they got the same thing. They did not even use this method at all.
But like the simpler one.
Well, they believe assumed mean is the simpler one, but the two is still the same number of columns that you have. Exactly the same number. Nothing changed. So for our assumed mean, we know that our standard deviation SD is equal to square root of summation f into x minus No, x minus m. So it's going to be c minus m squared over summation f minus open bracket.
Summation f of c. Sorry, c minus m. Sorry. C minus m. Okay. Summation. And the second one is square.
Yes. So this is the second one. So where what you have here, where what you have here is equal to d. What you have here is equal to d. Now I told you now that d is equal to c minus m. No, the one we did the other time was x minus m. So now our x is equal to c. You want to know it, you know it now.
C minus x.
Eh? No. There's no c minus x. It should be c minus x bar. X bar, yes. This is c minus m because we are using assumed mean. M is our assumed mean. So what do we need? I think we need f, we need c, we need c minus m. Do we need fc? We don't need fc. So let's make this not c minus m.
FD, what should be
fd is f into c minus m. So this is c minus m, which is equal to d. Then c minus m, okay, f into c minus m. That's our fd. Then c minus m squared. That's our d squared. Then this one is f into.
But do you know this thing is insulting actually?
It is
Insulting.
how?
That not give question like this, and then you are producing it just like one table and 4 lines.
We will show what it.
First one, life record.
So, ara ilé once again, ṣé ẹ̀ ń gbọ́?
Like same thing guys times. C minus m and C minus m.
No.
One gets square.
One gets square.
No, that formula. One gets square, one gets square.
See, this is everything all squared. This is
one thing all
squared.
One thing squared. Okay, formula is. It's no. Formula is to give us formula sheet.
Kí ló ń jẹ́ bẹ́ẹ̀?
Now this time just give us formula sheet.
So what are we using as our assumed mean? Our m is equal to, we say 167.
Why are we using 167?
You can choose anything. You like my use 1 million. It's your work.
Let's use 200.
No.
Why?
Because the value is big. No, this one now, the value will be small. The deviation will be very tiny. Okay, so our c minus m. We said our m, we are choosing 167. Okay. Now. So at Mopele might get 0. 167 minus 167.
Don't put the 0 through that.
No. So 152 minus 167. Change minus 15 here. 152 minus 167 minus 15. This one is minus 15 minus 10. This one is minus 5 0 5. Not sure.
Why would you have to return me? Why you going to go for example? Honestly, for you.
So, please let me check. Do the addition and subtraction.
So,
182 minus 167 should be 15. So, moving on. FD. Any imagine 0.
0.73 square and
0.5 something.
Why?
It will be smaller now. Anything that is smaller than 0, once you square it, it's just like you saying 1 over 25 squared. It's the same thing as 1 over 625. So, 2 carries in.
Yes, our FD.
Our FD, sir. eléyìí máa jẹ́ 60 àbí minus 60.
Yes.
Eléyìí máa jẹ́ minus 140. Eléyìí máa jẹ́ 13 minus 130.
Minus 140.
Then 21 times 5, that's 105. Then this one is 100. Then this one is, that's 45.
100.
And if you check our formula, do we have anything like summation FD?
Summation F.
D, yes. And this summation FC minus M. So, mo fẹ́ wo bóyá máa need àti add delay. I just need to know if we are going to add this one. So we are going to add this one.
Yes.
That's 45 plus 100 plus 105 minus 130 minus 140 minus 60.
It's good to have so that in the department.
So that's minus 80. Minus 80. So this one gives us minus 80, which simply means our assumed mean is greater than our original mean, which is true. Because our original mean is 166.27, but our assumed mean is 167. So, because this one gives us negative, so at the end of the day, it's going to remove from it.
So our mean was wrong.
No, our mean is correct. See, look at it. Minus 80 divided by minus 80 divided by 110 is equal to minus 8 over 11 plus 167. It gives us what? 166.27. Correct? So,
Look at the top answer. I didn't know you right there.
so
the man said we will write down also as confirmation.
talk.
If the FD summation is less this.
No, we don't need to write it though. Me, I'm just saying that that's how you know. No, before we actually found our mean. We found it to be 166. But assuming we never find mean at all, we just went straight to assume mean method. That's how you know that what you assume is actually more than the original value, because this summation FD will be getting negative.
How about the step myself it gets big number? But I don't look and I don't say the means or the mean. I just go pick like one.
Hey now, you did now, see now you did. 166 and 167.
Like, after looking at that, I know that the means should be around the middle. So I'll go and pick one.
You can't guess so. Do you know why you can't guess? It's due to the fact that the frequency may vary. Come here, C minus M squared. 15 squared is what? 10 squared is what? 5 squared. 0.
100.
No, it's 225. 25 squared is 625. So now that we've done this, the next thing to do is to multiply our d and our f again, our d squared and our f.
Sorry, you said when I look at this thing from
Yes.
150 minus, sorry to bring it back, 150 minus 154.
No, it's not 150 minus 154. It is between 150 and 154. This is class interval, it's not minus.
Okay, I thought this minus because I
No.
I was thinking of how to get
Okay, how did I get this one? How did I get this one? This is from the question.
Then 167. This 167 that is outside. I always get that one.
So let me just go by it again. You see, this is the class
I
interval.
don't let you calculate before you so that's what I'm saying.
Okay. So let's do our f times d squared. Our f is 4. 4 times 225 is what? That's 900. Sorry. 900. 900. Then 14 times 100. That's 1400. 26 times 25. Wow. That's
19,200.
that's one 300. I'm sorry, is it 1 300 or 130?
162,
I
no,
don't know.
it's 625.
Oh, that's 650.
Times 25, 650.
650. 650. Then this one is 32 times 0, 0. Then 25 times 21.
Better.
21
Yes.
25, I think.
Yeah, 21 times 25.
No, 525.
525. Then 100 times 10.
1,000.
Then 3 times 225.
7,
Okay. So going back to our this, we need to add this one together too.
5150.
Addition of everything, I mean.
Yes.
5150. The remaining thing we need to do now is to now go back to our original formula. That means our standard deviation will be equal to the square root of summation f into c minus m squared, which is this.
Oh, it was 6.8 you get now.
Eh?
6.8.
So that's 5150 over 110. 5150 divided by 110 minus, we don't make the same mistake again. This one is minus 80 divided by 110 squared. Minus 80 divided by 110 squared. So solving this now, what will it give us? So gives us square root of 5601 divided by 121.
Let m
Then finding the square root equal to 6.8 cm, which is the same thing as what we got from the beginning.